Welcome to today's presentation, and we will talk today about research involving human data and more specifically, what do I need to think of as a researcher? And as Rochelle mentioned, me and Markus are data stewards at NBIS data management team. And let's start with what is NBIS. So NBIS is a national infrastructure and constitutes the SciLifeLab Bioinformatics platform. NBIS provides bioinformatics and data science support to the Swedish life science research community, and we are around 130 experts in different fields distributed across 6 sites in Sweden.
So let's start now by with some definitions, so that it's clear what we will talk about this presentation. First, we have the concept of human data, which we think of as any data associated with or derived from a human being. And then we have the concept of personal data, which we will talk about a lot today. And by that, we mean information that refers to an identified or identifiable living person. And this is a concept that is defined in GDPR, General Data Protection Regulation. And then we have a concept of anonymized data, and that is data, personal data that has been stripped of any personal personally identifiable information. And then finally, we have a subset of personal data, which is sensitive personal data, that is special categories of personal data that need extra protection. And sensitive personal data is also a concept that is defined in GDPR. So we said that personal data is any information that refers to an identified or identifiable living person. So to better understand the concept of personal data, we will look at 3 examples. And we start with a single piece of information, the name Eva Johansson. Since there are many people with that name, we cannot use the information to identify a living person. Consequently, the name alone cannot be regarded as personal data. If we then add information about the city where a person lives, like Malmö in this case, there will be less people to choose from. But since there are probably many Eva Johansson in Malmö, this information will still not be, probably not be regarded as personal data. So lastly, if we add also a birth date, we will likely have enough information to identify a single person. And the example here to the right would therefore be regarded as sensitive or as personal data. Sorry. So it's a combination of data, combination of information that determines whether the information is personal data or not. So it's important to remember that data may or may not be regarded as personal data depending on the context. Then we have this concept of sensitive personal data. And sensitive personal data, as defined by the GDPR, refers to information that is particularly private or sensitive in nature. So GDPR lists several categories of personal data. The two most common categories in life science research is the health data and genetic data. And it's important to remember that processing of sensitive data, personal data, is prohibited except under certain circumstances, and research is counted as one of these circumstances. So when then does personal data become sensitive? We will now look at an example of how personal data record becomes sensitive personal data when information is added to the record. So like in our previous example, we have a name, a city, and a birth date that constitute a record of personal data. If we add to that record also information about the diagnosis, for example, in this case, diabetes type 1, we will make this record personal data. And this is because the diagnosis is health data, which is listed as a special category in GDPR. So now we have the basic understanding of these personal data and sensitive data. Then we will talk about two important roles that are defined in GDPR. And these are, one of the roles is the data controller, and the data controller is responsible for the processing of the personal data. So the data controller is said to be someone that determines the purposes and means of the processing. That is, deciding how and why the data is going to be processed. Another role is the data processor. And the data processor is someone, usually an organization like the data controller, that process data on behalf of the data controller. A common belief is that a data controller is the principal investigator, the PI of a research project, but that is usually not the case. In Swedish academic research, it's a data controller, typically a university or sometimes a hospital where the PI is employed. A data controller can appoint multiple data processors, but for each data processor, there need to be a data processing agreement that describes how the processing is going to take place. Two concepts related to personal data that often get confused are anonymization and pseudonymization. So anonymization means removing information so that data can no longer be linked to a person. Pseudonymization, on the other hand, means removing or replacing information so that the data cannot be linked to a person without the need of separate additional information. So an example of that could be when a researcher replaces a person's personal identity number, personnummer, with an artificial identifier. And this will make it more difficult to trace the data back to the data subject. So pseudonymization is thus a technique for protecting people's privacy or improving the data security. Importantly, anonymization is not regarded as personal data according to GDPR, whereas pseudonymization is. So that is a very important distinction. So now that we've gone through some basic concepts, we will look at what all this means to a research project in practice. So for simplicity, we will use three phases to describe a typical research project. And we will call the phases plan, execute, and conclude. There are different activities associated with each phase. And here are some of the activities that are good to be aware of. So I will start first with the plan phase. For example, during planning, you should start writing a data management plan. You should classify information that you are going to use in your research. You should, if you are using personal data or processing personal data, you need to register your personal data processing at the organization where you are doing your research. And you should make a risk analysis for the personal data. And if needed, you should also make a data protection impact assessment, DPIA. And before you start doing your research, if it's involved sensitive personal data, for example, you need to have an ethical approval, and that you must have before you start with the actual research. At the execution phase, you may need to collect informed consent from the data subjects. You should also document your decisions regarding the processing of personal data. And of course, you should follow good information security practices. And finally, under the conclude phase, you can share your data for secondary use, delete data that should not be saved, archive data that should be archived, and complete the documentation for your project and archive that as well. So we will look at some of these activities in more detail, and they are shown in bold here. So let's dive into the planning phase. If we start with the first activity then, the data management plan. That is something that's good to do early in a research project. The DMP should include information on what data you will use, how it will be organized, how it will be documented, and how it will be preserved and shared. There are several tools available. SciLifeLab offer a tool called Data Stewardship Wizard with questionnaires that are tailored to life science research. There is also a tool called DMP Online, which is more generic and offered by most Swedish universities. The next thing that is good to do, that many researchers forget to do, is to classify information. So data in research project should be classified based on its sensitivity and the level of protection it requires. The classification usually follows something that is called the CIA triad, which stands for confidentiality, integrity, and availability. The goal of the classification is to make sure that the data is handled appropriately based on its value, risks, and regulatory requirements. And most universities write about information classification on their website. But it's important to remember that universities may have different routines for how researchers should classify their data. Then we have this step of registering personal data processing. And controllers and processors are responsible for maintaining this record of their personal data processing. This means that if you plan to do research that involves personal data, you must register your personal data processing in advance. And here is just some questions that you might need to find answer to. The questions may differ a bit between universities, but these 6 are very commonly asked. Another thing that you should do if your project involves personal data is to do a risk analysis. And this might sound complicated, but it doesn't have to be. You can start really simple with just a simple table with 3 columns where you have like the title of the risk level, and security measures. And if it turns out that you have a lot of risk involved, or if you are processing sensitive personal data, you should probably do a data protection impact assessment. But I won't go into the details about that here. But this is also something that you can read about on your university's website. So now that was what I had. So I will now stop sharing and leave the floor to Erik again.
So first out on the execution part, we have the collect informed consent, and in parentheses, if necessary. And if your research project requires it, each research participant should be given informed information about the data processing before he or she decides to participate in the research. The process in which patients are given important information before deciding to participate in a treatment or research project is commonly known as informed consent. However, in Swedish academic research, this is consent according to the Ethical Review Act, and not the consent that is one of the law of the grounds in GDPR. And On this slide, we will have a 8-step recipe of how to pseudonymize your personal data. So when you have collected informed consent and received our data, we can apply pseudonymization. And first out, we have identify the personal identifiable information. We determine which elements of the data contain personal information that needs to be pseudonymized. Step 2, we generate pseudonyms, create unique identifiers to replace the original personal identifiers. These pseudonyms should not be reversible to the original data. Step 3, we replace the original personal identifiers with the generated pseudonyms throughout the dataset. And step 4 is about documentation of the mapping. So you should keep a record of the mapping between the original identifiers and the pseudonyms. This is crucial for any future reference or data analysis. Then we have the 5th step. This is secure storage. You should ensure that both the original data sets and the pseudonymized data sets are stored securely to prevent unauthorized access. Step 6 is about limitation about access. So you should control access to the pseudonymized data, allowing only authorized personnel to work with it. Step 7 should adhere to regulations. Make sure that your pseudonymization process complies with relevant data protection regulation, such as GDPR. And the last step, data validation. Validate the pseudonymized datasets to ensure that it still maintains its integrity and is usable for research purposes. And next on the execute section, we have the encryption. So additionally from pseudonymization, I will now present 3 parts of good practices around secure management. And we start with the encryption. So encryption transforms data into an unreadable format, protecting it from unauthorized access, where the strong algorithm ensures that even if data is intercepted, it remains unreadable. And a good practice is to encrypt the data at rest, for instance, the raw data when not in use. And if you want to try out how encryption works after this presentation, and those of you who have Mac and Windows computers can try software called 7-Zip to encrypt the file on your local computer. This is a handy default software and provides SHA 256 encryption on the fly. And let's say a few words about backup strategies to safeguard against data loss and data corruption. So even if the availability of secure storage options tailored specifically for sensitive personal data can be limited, the 3-2-1 backup principle serves a valuable guideline for all kinds of research data. This principle is an industry standard and recommends to have 3 copies of data, 2 copies on different medias, and 1 copy in a different geographical location than the other 2 copies. And when you have secured a backup, please don't forget to test your backup solution. And please remember to document your backup strategies. And also when you're using any storage solution, ask the providers of backup and demand backup. It's important as well. Next up is restrict access to the data. And this is the 3rd concept of the secure data management. And how to do this. So does everyone in the project need access to all the data all the time? One way to handle this is something called role-based access control. And this allows you to assign permissions based on individuals' roles and responsibility within the project. Role-based access control can restrict users while inside the working environment, for example, the server. But another thing that's important about restriction and access is passwords. And how strong should the passwords be? How often should they be changed and so on? And something that's available today and it's more useful, used as than before is password managers that can help out, keep track of your accounts and your strong passwords. So you don't have to keep everything in mind or note down on paper. And last part of this is also the different layers of authentication. Today, it's more common. It's becoming more common to use two-factor authentication. And multi-factor authentication is also coming a bit more and more. So you simply use either 2FA is two-factor authentication and MFA is an additional factor. For instance, if you have 3 factors, which is MFA, often you have something you know, like a password or a memorized PIN code. Then you have something you have, like a smartphone or a secure USB key. And a third factor can be something you are. So like a fingerprint, or a human with a fingerprint, or facial recognition. So when we come to the last part, let's conclude. So how share personal data for secondary use? What are the recommended options? Findings are published in a research paper, but never put any personal data in the paper. When the journal asks for data accession numbers, here are 2 possible solutions. So public repository for sharing anonymized data, for instance, aggregated data and RNA sequence count matrices. And then we have controlled access repositories for sharing sensitive data. And in Sweden, we are happy to present, we have the FEGA Sweden, which is the Federated European Genome Archive, which is a national repository for sharing sensitive personal data from Swedish life science research. And on the right side of this, you have also Array Express, and the upper symbol, and the lower symbol is the logo for the FEGA Sweden. And Array Express is the public repository for sharing anonymized data in this example. So when we reach the end of the project, what should we do? Research data should be stored for at least 10 years in Sweden, but personal data that is not needed to reproduce results should be deleted. And it's also important to remember that document the necessity of retaining any personal data and keep it safe and secure if you do so. So a summary of this presentation before we reach some full links and recommended sites. So personal data is any data that can identify a living person, and its classification depends on the context. Processing of sensitive personal data, for instance, health information or genetics, is prohibited except under certain circumstances, for instance, research. The data controller, often a university in research, ensures data processing complies with GDPR. And important as a researcher, you should plan your data management carefully, including drafting a data management plan. You should have know how to have the securing data. And you should also share it appropriately, anonymized or using controlled access repositories for the sensitive personal data. If you want to read more after this presentation, we recommend the SciLifeLab Research Data Management Guidelines. And this is a knowledge hub for the management of life science research data in Sweden. You also have a print screen on the right side, how it looks in the landing page. We also have the RDM kit. So this is a research data management toolkit for life sciences in Europe. We have FEGA Sweden. This is the Swedish National Repository for sharing sensitive personal data from the Swedish life science research. And then we have a couple of more. We have the Swedish National Data Service, SND. This is the General Research Data Management Guidelines in Sweden. IMY, and that's the Swedish Authority for Privacy Protection. We have the Swedish Ethical Review Authority, and then of course, your university's website. And who can you contact with any kind of data management related questions? We have, of course, the university's research data support, often located at the university's library, but it can be different from universities. You have the data protection officer, the DPO of your university, and answer questions related to GDPR. And you are most welcome to contact us at SciLifeLab Research Data Management Support, and you can email us at data-management@sciliflab.se. And if you have any questions related to publication or submission of sensitive personal data, you are most welcome to contact the FEGA Sweden help desk at ega-se@nbis.se. And here are just two examples, resources at the SciLifeLab Research Data Management Guidelines. We have a summarized page with universities' RDM research data management resources. So contact information to the different units at the universities that are working with research data management. And also further down on the same page, you have contact information to the university, most of the university's data protection officers. And on the right-hand side, we have also available fruitful information about sharing human data and related topics to that. That was it for this presentation.